for being on the panel. So a little background on this. Sarah and Nancy asked me when we were in DC for AASHTO Maintenance Committee Conference to put together this session on NDE, and what resulted in that was we sent out a 6-question survey to all the state DOTs that are part of Midwest. We got all those results. And then today, essentially what we decided to do was kind of go through some of those questions and have the panel members from state DOTs kind of discuss their experience with non-destructive testing and evaluation, what technologies they've used in the past, what their experience has been with those, what types of elements that they're typically inspecting, whether they've had success or limitations with those. Typically how they go through the contracting, do they have in-house expertise, and so on and so forth. So thank you guys for joining, and I think what I'll do, I sent out a couple questions to these guys over the last few days. We're going to kind of just go through those questions again so that the audience can hear their responses. I'd ask you guys to be a little more detailed in your responses there. So I'll leave the questions relatively broad. Give as much detail as you can. So if you have experience with one specific technology, like Philip has used a lot of IR, as we've heard in the last hour or so, but it doesn't have to be just for decks, right? We can talk about steel, we can talk about foundations, so on and so forth. Try to give the audience a little bit of your experience, and obviously in the audience, if you have questions, let's try to treat this more as a discussion than a lot of panel discussions where it's the panel talking and everyone listening. So with that, I'll get started. I'll ask the panel here, in the last couple of years, what has been your experience with non-destructive testing and evaluation? What are the problems that you're trying to solve? So if you're looking at a structure and trying to evaluate it, what is the problem you're trying to solve, and how have you utilized NDE and T to address that problem, and what are your success? Paul, do you want to start since you gave us the biggest detailed response there?
Sure, yeah, this is a wide-ranging panel, so I did put some thoughts together, but NDT can use for just about anything. I think our fracture critical unit, they're using MT and ultrasonic for their routine work. But they have a little thing, a D meter, that is probably the most simple tool to measure thickness that we use quite a bit in construction, and when we're scoping. We need to know how much section is remaining on some steel girders. That's what we use, is to map out the section loss in the steel with the D meter. And we have 2 units in-house of this handheld GPR unit, and I think that's the second thing that we found the most useful to our agency. Those things are always checked out, these handheld GPRs, to locate rebar or to avoid rebar when you're coring. So as far as simple things that are NDT, that's what I think of. But the problems we're trying to solve that we would contract out, we're looking for deck surveys to get better quantities for repair projects or better decisions made. Chaining is still the gold standard, but we can't get out in traffic, so sometimes we want the GPR on the cover, because cover is very useful in making decisions. And then we haven't really found, we're trying infrared. Wisconsin's way ahead of us in that, but we just haven't had the faith in it, and it seems like we're spending more time validating than actually believing, taking the results as good inputs. So we just have been more reserved on the use of infrared. A couple other techniques that we use, we have this timber stress wave timer. I don't use this, but they told me about it. So it's for timber piles and stuff, to measure the integrity of piles. We have a lot of state aid bridges out there that use timber piles yet. And then this timber resistance drill, and both of these have videos on our website for the state counties to use those tools or check them out. But I could talk a lot more on different things. We did have suspender cables on a bridge that were problematic. We were looking and researching what techniques were available, ultrasonic or this long-range guided wave ultrasonic to check when do we have to replace these suspender cables. It's a conundrum. And where they meet the socket, they've really corroded out, and there's no good tech to find out what your section loss is at the socket. So we're proceeding with a repair project to first investigate section loss and then to rate it to tell us when the best timing is. And now we got some funding, and we said, let's just replace it rather than spend all this money trying to find the optimum timing for cables. So sometimes you could spend a lot of money on NDT to still come up with questions that leave you not feeling good. So I don't know, you just have to call it a day sometimes and make a decision. But I think somebody else probably have better input on their use.
Well, so one follow-up question on that for the audience. You said you had a couple handheld GPRs. Are those just GSSI structure scan minis?
Correct.
Okay. So for everybody to know, it's just a little handheld unit. The display comes right out, so you can kind of see the scan as you're doing it. You can also take the data back and do a little analysis afterwards. So it's a nice little handheld unit that GSSI will provide the training, or another vendor can do it as well. But pretty nice little unit that you can use in-house. And then on the D-meter stuff, you guys are doing that all in-house as well? Cool. Adam?
Yeah, so from an Indiana standpoint, I'm in asset management, so I'll kind of give you that standpoint as far as instead of inspection. But we mostly use NDT on a project level. We don't do a ton of network level yet, although we've purchased some additional equipment that we plan to do it. So, but mainly we use it for deck deterioration, to help us with programming deck versus an overlay versus a replacement. We also use it after construction if we've got construction defects to determine the cover depth, or if we have other defects, such as if they put the bottom row of steel on the bridge forms, which was just recently last week happened. So we need to determine the voids in the concrete. So we use like a handheld GPR unit, like Paul discussed, on the bottom, and then a walk behind on the top. And we also use it like after accidents or damage. So I think a couple years ago on the east side of Indianapolis, I-70, the ramp from I-65 to I-70 east, we had a bridge tanker truck filled with jet fuel that crashed and spilled over the deck and burned up. So we used a combination of the hammer test and pulse velocity to determine the concrete strength of the deck and the barrier rail. And also the MSC wall panels that were next to it. We did some deck cores, and then we also used GPR on the MSC wall panels for the connections to determine what needed to be done to the bridge and if it was safe to open it. So, but those are the main things that we use it for, mostly right now on a project level, not so much on a network level.
And then, Adam, you guys just did a study with Purdue on bridge deck stuff. If I recall, it was infrared, high-res, automated sounding, and GPR. How will you all take that research and push it forward throughout the state?
So yeah, that study, it was a combination of NDOT and Purdue University. I think it was 4445 that did kind of looked at, like you said, a bunch of different NDT methods. I think we had 6 or 7 different methods, maybe 9 different contractors, consultants that did the testing on maybe around 100 bridges across the state. We did it in kind of 2 phases, where we looked at different methods or the same method from a different consultant to try to see, what type of consistency we had between the reports and what differences we had. And then trying to take all that information and figure out what's the best method for network level, and then what's the best or combination of the best methods for project level as well.
Really good study, especially, we'll get to this a little bit later, but kind of the discussion on vendor to vendor, the contracting and procurement process of, do we need to go qualifications based or cost based, and maybe we can talk about that in a bit. Philip?
So yeah, I guess in addition to the regular inspection, NDE, focusing on deck and slab, we use GPR for rebar depth, overlay thickness, determining contaminated, deteriorated concrete. We'll use impact echo sounding, coring to spot check and validate. We'll use chloride ion testing. I know that's semi-destructive before certain preservation treatments on older decks and slabs. So yeah, I guess looking to branch out for NDE on decks. We're evaluating GPR for the percentage of contaminated concrete. What can we identify decks that will develop DLAMs in the future? IRT by drone, under deck thermography and sounding, looking into automated sounding systems now, and automated crack detection. So those are kind of that group that we're evaluating in addition to thermography that we're typically using.
Okay, and then other than decks, does Wisconsin do any NDE monitoring, those kinds of things?
So we also do GPR for retaining walls. Yeah, and then it's typical inspection, UT for your pins, meg particle for fracture critical, D meter, stuff like that.
Or do you sub it out?
It used to be in-house, but we lost the expertise there, so it's mostly subbed out.
The reason I ask specifically is a lot of times steel NDT is quite a bit older in the civil infrastructure industry because it came from oil and gas, aerospace, nuclear. So there's a lot of expertise out there, and a lot of state DOTs have that experience in-house. Whereas the concrete stuff, it's less standardized and mostly it's consulted out. So thanks.
Yeah, we have somebody that's very interested in drones, and so he's also, when he's out on inspection, he'll use drones and he'll use thermography to get a feel for where the deck is at and see if we need to do more in-depth inspection there.
Got it. Todd, it skipped you. Go ahead.
Oh, I didn't know where Mike was. I'm Todd Miller, Missouri DOT. I spent most of my career in program delivery, and really the last decade has been in maintenance. But a lot of things haunt you when you go from program delivery to maintenance. But one of them in program delivery was essentially bidding out partial depth deck repairs. We had several jobs that we bid out, and one thing in program delivery and now, I don't like wasting money. I don't like spending money on risk. MoDOT's an engineering agency. I like to engineer as much risk as I can out of a project as possible. So don't like losing money to risk. Sometimes you have to, but if you can engineer it out, let's do it. So we had some projects that occurred while I was in program delivery where it was essentially a partial depth hydro demolition job. We felt very strongly that there wouldn't be any full depth at all on the job. We did go ahead and we had a price for partial depth, and we went ahead and included probably just one unit, 1 square foot or 1 square yard, whatever it was, of full depth. So we proceeded with the job. The bid was very imbalanced. It was very competitive bids on the partial depth and extremely high bids on the full depth. So what happened? We ended up with a bunch of full depth on the job. I wasn't there. We weren't there watching the pressure on the hydro demolition, but the bottom line is we had a huge overrun on our full depth and paid a lot of money for something that we really shouldn't have. So when I moved over to maintenance and we went through that, and it actually changed the whole way we bid these jobs. Now we don't allow the unbalanced bids anymore. It has to be pretty much a standard bid between the partial depth and the full depth. But that's kind of putting a restriction on how people bid a job, but that it did change the way that we set up the whole bidding process. So when I went over to maintenance and I saw and I'm sure a lot of people have seen this graphic of a GPR scan or a ground penetrating radar scan of a deck, and then the hydro demolition superimposed on it, and it just matches almost perfectly. That very much piqued my interest. to have that much more knowledge as far as in the program delivery phase, and to know what's going to be out there as far as what are the possible outcome of this hydro demolition on this bridge deck. So that really piqued my interest in hydro demolition and non-destructive analysis. But Missouri, we're really not heavy into it. We did have some ground penetrating radar on some pavement subsurface work that we also went ahead and scanned some bridge decks with to kind of play around with, and so it really isn't something that's prevalent. Ideally, I'd love to be able to just scan an entire bridge and see every possible failure that's either imminent or could be occurring on any part of the structure of a bridge, both the internal and external. One other thing I'd like to mention with Missouri, and this is something that was kind of in the works for 10 years, and I finally did something about it this last summer, was we're talking about basically non-destructive testing for failures. Well, I'm kind of proposing a non-destructive test for possibly a success, and what it was just we have essentially done a lot more bridge deck sealing than we have in the past. We try to get about a average 5-year cycle on bridge deck sealing. We were about 10 years ago, we were gonna do that through a more of a performance-based process. So we thought, well, what would be the performance base? And really, you don't want water to be able to enter into that bridge deck. So we thought of the idea of let's get kind of a hydrostatic, essentially a permeability tester, and just have a graduated cylinder that just measures how much water soaks into the bridge deck. And we toyed around with that about 10 years ago and never really moved forward with it, and never moved forward with bridge deck sealing through a performance-based contracting. So finally, I got a summer intern this summer, and I had him just perform various tests using hydrostatic permeability testers, typically used on asphalt, but use them on the bridge decks, and just kind of see how much water these bridge decks soak in. How successful are we with sealing them? And it was a lot of interesting results. A lot of results that are really what I expected. If we grind down a bridge deck to get a nice longitudinal profile on it, it's going to soak up a lot of water. That's just what I suspected, and that's exactly what this showed. So we learned a lot of stuff from that. But really, that's kind of non-destructive testing rather than cutting out a piece of the deck and checking for the resistivity of the sample that you have. We're just seeing the bottom line, how much water is soaking in their bridge deck. So it was some very interesting results, and really kind of led more to maybe we're sealing a little too often. Some of these bridge decks just stay tight, watertight. And even we measured some right before we were getting ready to seal them again. They were still holding their own as far as keeping water from entering them. So that's kind of the Missouri experience with non-destructive testing.
Great. So, I mean, you bring up a great point. I mean, we don't always have to talk about, technology that is has an ASNT standard.
Yeah.
The main point of non-destructive testing, evaluation, monitoring is all to just get better data so that we can have that data to make improved decisions for the assets, right? And so if you can use that data, whether it's a homemade permeability test or a GPR or whatever, you can use that data to better improve your asset management, to be more proactive in your preservation, which is what we're here, this week talking about, and to ultimately utilize your funding better. So great point. Thanks.
I think in Ohio, when I think of NDTA or NDE, I think of deck surveys. We allocate half of our funding to deck replacements, which is it's a big number. And so if you're interested in how we, scope or some of the commentary behind the scenes for doing deck surveys, our bridge design manual, section 400, goes into better detail than what I can give here for deck surveys. But basically, we want 2 or 3 different methods to correlate. Should we do a deck replacement, or should we do an overlay? Or should we do a second overlay or a third overlay? And we really throw the book at it for larger bridge decks because that's real money. As we saw in Philip's presentation, it's a big difference between an overlay and a deck replacement. And we want to get it right. We don't want to spend money we don't have to, or have to go in and redo the deck, change order. So if beyond the deck surveys, let's see, we've used chloride ion testing to decide when to overlay bridge decks that we just cannot replace. So cable stayed structures. We really want to do an overlay every 10, 15 years, maybe if we have to. And we use, it's a bit of a destructive test. But I think your original question was some success stories. So that's what drones have been a big success story for us. For our season, we had a UT gauge that wasn't just a spot measurement with a transducer. It was a wheel that was a pitch and catch on the same wheel, two different sides, and it would measure every 0.01 inch as you rolled along the weld or as you rolled along the beam. You get that profile that's really valuable for relating to area steel for capacity checks. We use LiDAR and side scan sonar within the past 2 years. That's been very helpful for visually telling what the problem is, so we can compare to baseline. Beyond that, we use for impacts and cracks we find for steel. Finding the crack tip for drilling it out and watching the length of the crack grow. It's kind of like stuff that we already found visually, but we're going to monitor with NDT.
Does anyone in the audience have challenges or successes that they've had with NDE for their state agencies that you'd like to discuss? So, we talked about some of the successes.
Shane, I could add something.
Yeah, sure.
I was abbreviating it because we have a lot of time here to spend, but I do think the issue of post-tension bridges remains a challenge for us, that locating the voids in the ducts and the volume that you might have to fill. We actually had a research project with Janie Elstner about how you even contract that out. You might have a void, so then you pay somebody to get into the box girders to find them, but then you don't know the quantities that you'd have to contract out. And so half the battle is verifying the NDT, it finds the void, and then the volume, and by the time you're done patching it up due to the verification, you've paid so much for access. So it is a challenge to our industry, is just how do you quantify post-tensioning voids and contract that out for taking care of those voids.
There has been a good bit of research, both by Federal Highway and independently. NCHRP 1428 did a fairly large study on NDE for PT ducts and pre-stressed concrete. Typically it's a lot like a bridge deck. We're using GPR and acoustic methods to be able to identify and hopefully quantify those voids. But like Paul mentioned, every part of NDE is also validating that. And by the time you get in and drill and excavate, map with inside the duct itself, maybe with a bore scope, or take some grout samples to see if you have a degradation mechanism, measure if you have any cross section of the tendon, you've gotten into a good bit of cost and time, right? So a lot of times, utilizing this on projects where you can use it as a screening process to identify if you have a widespread issue or maybe it's localized. And then also, as usual, it becomes an economy of scale. So, when you're applying it on a signature bridge, maybe you can do a lot more of the structure. And then, ultimately it ends up being less expensive for the owner because they can identify that they can save the structure rather than completely replacing it. A good example, West Seattle High Bridge, owned by Seattle DOT. They were under the impression that they were going to have to actually completely replace the structure. And we went through and did PT duct inspection, identified that it was actually a torsion issue with the structure, a design issue initially. And they were able to go through, retrofit it, put some carbon fiber wraps on it to reduce that torsion, and ultimately it saved them $1 billion in replacement. So sometimes even when the NDE cost is extensive and it takes a little while, it does end up saving you money in the long run. So kind of a double-edged sword there. We kind of talked about successes. Paul, you kind of started us off with some challenges there. Do we want to go through some of those? Aside from PT ducts, what other challenges do you see that you have with your assets that could potentially be solved by NDE, but maybe you haven't experienced it yet, or you don't know if it's even out there? What are those problems we're trying to solve?
Yeah, maybe I mentioned it with the post-tensioning and it started off ahead of you. But I see the correlation remaining on decks that we need to be smarter about our NDT and say, what are the decision drivers for redeck? I mean, if you can identify the lane that's really going to be the problem lane, do you need to survey the whole bridge kind of thing if you're on the shelf between a redeck and a preservation technique? So we'd like to get to a place where we can be smarter about selective NDT with respect to decks. And we have a road doctor van that we're going to try to also see if the technique they're using for asphalt can be used on bridges. But I guess other challenges are piles. We have a lot of steel pile corrosion, and unless you have low water, you might not see it, and it's hard with dive inspection to get good estimates of section loss. So when we had the drought this last summer, we were finding all sorts of corrosion levels that we weren't aware of, and now we're going to be into high water probably next year when we need to repair it. So it might be an underwater repair rather than a dry repair. So the piles remain. We have a lot of pile bents, and the combination of scour and section loss on pile bents is not a good combo. So it remains a challenge for us to identify those and even figure out how do you take the right measurements that's going to give the analyst the information they need, because section loss and pile bents is very erratic, and the critical section, depending on scour, can vary.
Kind of follow up on that, if anyone in the audience has heard me speak before, first off, I apologize. But secondly, I typically talk about the difference between non-destructive evaluation and testing. So just like Paul said, it's always very important, instead of just saying, okay, I'm going to go test this with this particular technology, to evaluate your structure and identify what you're trying to find out, and then from that, what technology actually works, right? So don't just throw a single widget at something. Identify what you're trying to determine and then find the right testing mechanism for that.
Yeah, so at Indiana, one of our challenges, we like to do a lot of LMC overlays. So of our approximately 5,900 bridges, about half of those have an LMC overlay that are getting older and older. And probably half of those, so maybe 750, are rated 5 or below, or rated a 5 or a 6. And so one of the things that we've been doing is using Impact Echo. We've got a couple trailers with walk-behind machines that will go out and map the whole deck out, and we're using epoxy injection to try to get an extra 5 or 10 years of life out of those bridges. So where we actually have a whole setup. A couple districts have the vehicle at their use that they can go, and I think we've done maybe upwards of over 100 bridges in the last 3 or 4 years. We've had really good success doing that, so we've mapped it out ahead of time, then done the epoxy injection, and then we'll map it afterwards, and the percent deterioration drops from maybe 20% down to 2 or 3. So that's one of the issues we've been having, and how we solved it. So
what's a major challenge we're trying to solve?
Yeah, so
using NDE.
Yeah, so what problems are you having with your assets that you think could potentially be solved by NDE? That maybe the technology doesn't exist or you haven't heard about it. Essentially, if you could solve a problem with your assets that you haven't been able to do so yet, non-destructively, what would it be?
I can't speak too well to the inspection side with some critical issues. I've been focused more on the deck last few years, so just tightening up that prediction of when to do the overlay, when to do the redeck. Yeah.
If you could improve something about your current program, what would it be?
Find an NDE that is 100% accurate.
Good luck.
Yeah.
If I find it, I'll let you know.
As far as challenges go, I actually have 2 offices in Missouri. One's in Jefferson City and one is at Lake of the Ozarks. And we had two essentially bridge rehab projects. One was a couple years ago, Missouri River Bridge in Jefferson City. And it was a lot of structural work, structural rehabilitation. But when I was talking earlier about, your scope can increase, that's going to impact how much you spend. I was complaining about spending money, but also it impacts your schedule. So a couple years ago, the Missouri River Bridge in Jefferson City, I think it overran on its schedule several months, maybe in the tune of 6 months. I can't remember. You kept hearing the complaints. You just kind of, the months kind of melted into each other after a while. But so then you have that you're dealing with. You're increasing the schedule on the project. The bridge is closed down that much longer. You're catching that much more heat from the general public, and it's all because you probed pack rust. You took a look. You estimated what your scope was going to be, and then when they started sandblasting, it got bigger, and the time frame it took to fix it took a lot longer. So that's really a challenge. So it not only happened in one of my offices in Jefferson City, but then at Lake of the Ozarks, essentially the bridge that's over the dam that makes Lake of the Ozarks. We had a rehab project on it. That was mostly deck and joint repairs, but same thing. We ran into some issues. The schedule was supposed to be done by December 31st or January 1st of last year. We had gorgeous weather, the best possible weather you can imagine, all the way up through the end of the year. Then finally it got bad, but we weren't even close to being done. And that's my hometown. Serve on committees and school boards with people that had businesses right adjacent to it, and it stayed closed. And they really wanted to stay out of the summer. The summer industry is the biggest industry there, and I think we finally got things open in March or April. So it was getting pretty close to the summer season, and I was definitely personally catching a lot of flack for that project. So really, another challenge is using non-destructive evaluations to essentially, again, like you said, get your scope 100% correct, and that way your schedule can be 100% correct, and the amount of money you pay for it can be as accurate as possible.
So another good point there. Have you all struggled with the turnaround times from testing to report? Yeah.
As far as turnaround, we haven't dealt with a whole lot of non-destructive evaluations, so I haven't really had an issue just because we don't deal with that a lot. So.
Got it. Yeah, to answer that question, I'd say no. We haven't had trouble with turnaround time.
Okay.
One thing we're trying to work on with Dr. Washer is doing infrared on new paint. So one of our current ways of testing whether or not the contractor put paint on correctly is just a little small area at the abutment with a little scratch test, and contractors know that, okay, we're going to do this area really good. And so we're investigating infrared for cohesion and adhesion failure for bigger swaths of the steel. We spent protective coating systems, one of our top 4 areas of allocation. So we really want to get the paint right. We've been burned before with paint. And so that's a challenge. That's a problem I'd love to see solved. Any way to automate that to get a bigger swath. The big thing I would say is trusting it, is trusting NDE or NDT without going out and doing a separate correlation or I really wanted to, delaminations really drive a lot of our program if we boil it down, like Paul said. So how do we get the delaminations and what are the tipping points for replacement or rehab or just, monitoring? And so getting delaminations at freeway speed has been kind of like something I've really tried to get. And each time I've gone after funding, $50,000, $100,000 test, and I've gone back out and chain dragged and done my own testing. I've found a bridge, 2 bridges, 3 bridges out of 20 where it was completely wrong. So trusting the NDT has been my biggest challenge because I want to believe it. I've got these problems I need help answering, but I can't always get there.
Right.
Yep.
Working with a number of contractors recently is just the range of expertise in that field is dramatic. And if you Yeah, there was one contractor that was just way off. I told him. And I said, do not market to other states because you will hurt the industry. And what do? They market to another state. So there's a whole range. You need to check up on them. You need to cross-validate. There's another contractor that we have, super diligent, like on their own time, go back out. We didn't get a good reading this day. Let's do it again. Let's sound it because we're not sure, you know. Let's go the extra mile to make sure we're as accurate as possible. The difference in those two mentalities is dramatic, and you have to know who you're working with.
Yeah, so on that note, it's a good segue to the next topic, talking about procurement. How do you procure good services, you know, quality-based validation studies? I hate to even say this, but low bid. Can you talk about a little more on how Wisconsin has done that? And
So we have a solicitation for a master contract, so that's quality-based. So you can get we've found a number of good contractors that way, and then you get into using them. Like that's the only way that you can talk all day long, you can talk theory all day long, but until you're out there, you're dealing with that specific bridge, and they've got that specific cost attached to that specific bridge. It's not until you're working with somebody that you really know exactly what processes they're doing in the field, their QC, their mentality, all that stuff. So we like to give everybody a shot. It's a whole onboarding process every time we have a new contractor, which is a struggle for resources internally, but it's worth it when you find other contractors that are quality contractors, and I won't even say you can trust the results. It's just understanding what quality you're getting for what you're sending them out there to do. Like each of these technologies is going to have a different piece of the puzzle, and so you just need to understand and be okay with, it's going to be cheaper to do this instead of that, but I'm okay with that because I need to scan twice as many bridges or whatever. So.
Is there a way to mitigate that so that each state doesn't have to go through a trial and error? Like I know we're talking.
You can call me.
Do what?
Call me.
Call you? No, I just mean in general. I mean, there is quality based, right? And we do quality based procurements. But then if you have to do a quality based procurement and then you get a contractor like Contractor A you were talking about, that you're like, don't even go market to anybody. How can we mitigate that as an industry?
Talk to each other.
Okay.
That's what I love about this conference is just sharing. I can throw up what we're doing in Wisconsin and feel free to say, that's ridiculous. Like I would never do that in our state. And we can have that discussion. We can talk about who we've worked with in the past and what kind of results we've gotten, how we validated them, and work through all of that and just figure it out.
Man, I hope I don't make that blacklist.
Yeah, and I think one thing that we noticed through that SPR study with getting multiple different contractors, even testing the same methods on the same bridge, is that everything was done differently. I mean, so maybe a standardized process for collecting the data, for mining the data, and for reporting the data. I mean, we had some results that some people just recorded the percent deterioration. Others said, oh, it's a severe and a fair, and others said there's, three categories. So just inconsistent. So you had to try to compare the two, having different maps and different categories. So that was one of the challenges is when we were looking all that data to try to figure out, I mean, you say accurate, but how do you define accurate? And I think trying to compare it to different methods is one of the things that we did to try to see, which one did correlate well with each other and which one was repeatable and what other factors maybe that we didn't take into account, like weather and stuff, that maybe there needs to be more standardized process for some of that, those processes.
Yeah,
so.
Unfortunately, well, it's fortunately, but unfortunately, almost all of these methods that we're talking about, specifically for decks at least, the steel side is riddled with standards, but on the concrete side, there's actually ASTM standards for almost all of these. The unfortunate part is they're all about 30 years old and haven't been updated in that time frame. There's actually a standard for chain drag. I think you all probably know that, but there's nothing for automating that process. There's nothing for comparing one type of GPR to another type of GPR. So a lot of work to be done there, especially on the standard and procedure side.
I think the original question was about contracting, or?
How do you guys
Procurement.
contract? What are the challenges you see from contracting to getting the report? What steps did you miss? How can you make it better?
Sure. So, I mean, if we bulk 30 bridges or so that we want, it's going to go out to competitive solicitation, and then the panel grades the proposals and, picks the best value. If we can contract with direct select up to 25,000, if the scope is kind of partially defined, but if we have a really tight scope, then we can go up to 100,000 under direct select. Working with somebody that we feel gives us good quality rather than go through the risk of a shiny proposal that looks better than another. But I guess the challenge is we usually package it with another contract. If we just want a survey, it's just going to be GPR combined with infrared or some kind of multiple methods from. But if we want to know what preservation action to take and get actual quantities for repair, then it's usually with another provider, and then the NDT person is sub to them, so it's a package deal. So I guess that could be good and bad. It just means working through more, the sub and the prime, and getting that best proposal overall. So I don't know if that answers your question completely, but.
Well, in Missouri, most of our contracting is essentially, design, bid, build. The aspect of non-destructive evaluation or analysis, to me, that's something that in what we our usual methodology, which is design, bid, build, that would be part of the design process. So it would be a consultant or qualified based selection. And in qualified based selection, I require references. I look up those references to see how qualified the proposals are. And again, the basis of the qualified basis is whoever's most qualified. That's who you start to negotiate with as far as prices and go from there. If you do come to an impasse as far as prices go, then you have to look at other places. But I see that as part of the essentially the design side of the project delivery. Now we are doing more and more full package design build processes, but that also has a qualifications based component as well as a pricing, which are weighed out. So no matter what, you're going to have a qualifications evaluation on whoever it is you're choosing for the non-destructive analysis. But really, the bulk of how we do it is that would be part of the development of the project, and then you go to the low bid once you have a project developed. But hopefully, with non-destructive, you'll have a lot more clarity on the scope, and you won't have schedule issues, and you won't have cost issues and overruns.
Our decisions would be project level, similar to probably, I think I've heard that. Project level decisions, what's the best decision with this bridge? And that generally happens within a scope that we would make in-house, and it would be a consultant selecting their team. The NDE or NDT person or firm would be part of the team that the consultant selects. So it happens, and in a consultant, we have a very structured way that we select, a programmatic way of selecting consultants and teams. For structural health monitoring, we put that kind of stuff into very large, complex structures like cable stays or big post-tension box girders. It's a big cost, but small compared to the cost of the overall structure. And so that's when we would hire a university in Ohio, in the state of Ohio, and they would reach out to industry for help, or they just have a bunch of grad students do it. So that's the second way. Third way would be emergency. We'll throw as much money as we can at this just to get the bridge back open or to get the road open underneath. And so those are the three primary ways that we would hire. Qualification based, I think we set the floor at I don't know what the level, the technician level, but we set the floor for a technician level. I don't know if it's 2 or 3, but so that's how we get the qualification.
I don't really need this, but you talked about certifications or tests or standardized, something that will help you get consistent. How do we do that? So it's obviously a problem. It's a problem for all of you guys have dealt with it. I think every DOT that's done NDE had work done. You deal with the issue of getting what you want and making sure that the test or the work is being done correctly. And how can we band together and affect that? It's a question for you or anybody, but.
And I'm not really going to have an answer, but at least I'll have some perspective. I was in pavement preservation, so basically our partner on the pavement side of things has developed certification for chip seals. So the Midwest Bridge Preservation Partnership has developed certification. Again, not an easy process to go through. You don't want to process. Anytime you have a process that's going to exclude people from being able to bid on something, you have to make sure you do that correctly and that it's and it's going to deliver the results that you want. So just from a perspective standpoint, I can say having jumped from Midwest pavement over to Midwest Bridge Preservation, they have put that together for chip sealing over on the pavement side of things. So it is something that this type of group has successfully done before. And when I say successfully, I mean they have the certification and training set up for it. So, and that was happening as I was leaving, so I can't really give you all the details of it. But it was something that was done, and it took a while. It took several years to get it developed.
So from my perspective, it's primarily bureaucracy. And it's not just bureaucracy of one agency. We've got, in this particular industry, you have AS&T, American Society of Non-Destructive Testing, ACI, AASHTO, and Federal Highway, at a minimum, that you're looking at to involve all the people to try to develop such a standard or procedure or whatever. The issue is that each of those organizations has their own agenda. A lot of the times, particularly with AS&T and ACI, those are volunteer positions. So it's getting people, just like, with this organizations, to volunteer time to get that pushed through AASHTO, pushed through Federal Highway, vetted. Long-term bridge performance program is hopefully going to be a good resource moving forward. They have developed a set of guidelines for a particular test. John Popovich out of U of I and his ACI committee are working on another set of guidelines. I'm hoping that my AS&T infrastructure committee can start coalescing those, but we've been doing this 15 years, and that's just my purview of it, right? So it's a challenge, and having one contractor come out, give results in green, yellow, red that mean different than the green, yellow, red from another contractor, right? How does that correlate to condition states? What does it mean for repair? I honestly don't have a good answer, except that it is a problem. All right, well, we're right on time. Thank you for the panel members.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.